Finally, we'll look at how to use Golangci-lint. So what are linters? Linters are static code analysis tools, and that just means that it analyzes the code without executing it. By analyzing the code, it identifies and flags patterns. These patterns are related to potential bugs or code style issues. A small piece of trivia, the term linter originates from a Unix utility that examined C language source code for code smells. So why should you use linters? The first and foremost reason is shift-left testing. The idea of shift-left testing is to try and do the testing in an earlier stage, which you otherwise would have done in a later stage. The objective of doing this is to try and detect issues earlier. By detecting issues earlier, the cost of fixing the issue is actually reduced. It is much cheaper to fix an issue in an earlier stage compared to fixing the issue in a later stage. And this faster feedback allows us to actually deliver work of improved quality with a better speed. The quality is improved because we are otherwise detecting issues which we might have missed. And the speed is improved because it takes lower cost to actually fix the issue. Now, if you think of the feature lifecycle, you have product requirement gathering, architectural design, implementation, unit tests, integration tests. Now, fixing an issue that you have identified just before rolling it out to production is going to be much more expensive depending on the type of issue compared to detecting the same issue during architectural design. So this aspect is quite important. And in the context of linters, what we are talking about is moving the detection of bugs from unit tests and integration tests to the development stage. The next aspect is linters that can enforce code style. And the reason to use such linters is to bring consistency to the code base. This consistency helps with readability, and readability in turn improves the maintainability of a code base. In addition to that, it also helps with a slightly faster speed of delivery, because now you have, again, the whole faster feedback loop, right? So a feedback that you might have gotten during PR review, you can get it right during development, thereby reducing the cost of fixing that issue. It can also avoid inconsequential debates. This is seen, an example of this would be what Go did with Go FMT for the tabs versus spaces debate. It ended that whole debate for the Go community, right? So you can do that on a smaller scale by picking these micro decisions for your entire code base and ensuring that everyone follows that for coding. The last aspect is that a good linter setup can act as guardrails for both experienced as well as new developers. It is more helpful for new developers because it can make them aware of pitfalls that might exist in a language or a library. And in some cases, linters can also help with catching bugs which are harder to catch in tests. To understand how linters can actually do this, let's look at some examples. These examples are a bit contrived, but that should be okay for the purpose of this discussion. So let's look at our first example. Here we start with a custom type myError. It implements the error interface. And we call a function do something which might return an error. There is some error handling for it. Part of the error handling is to check if the error returned is of type myError. And if it happens to be of type myError, we try to do some basic error handling on it. So can you spot what is the issue here? Yes. All right, so the issue is that errors.as expects that the second parameter passed to it should be either a pointer to an interface or a pointer to a type that implements the error interface. Now, in this example, we are passing the address of a variable of type myError. But the type that implements the error interface is pointer to myError. So the fix is to actually pass the address of a variable which is of type pointer to myError. This issue can be detected using GoVet. GoVet includes a few other checks as well. And in fact, whenever you run Go test, it runs some of these high confidence checks that are present in GoVet as part of Go test as well. You can get more information about each of the checks by running the command that I've shown here. Next example. So here we have a demo function. We start by parsing a URL. We instantiate a search params value and call set query params. Inside set query params, we are calling u.query.set for the 3 params that we want to set. And finally, we are printing the URL, and we expect it to look something like this. Let's see what happens when we run the code. So what we see is that the URL doesn't have any of the query parameters that we tried to set. So can you spot what is the issue here? So the issue is that url.query returns a copy of URL values, and any modifications you make on it do not reflect on the underlying URL instance. So this particular issue can be detected by static check. Static check is a very good linter that includes many detections, and it mentions the same thing, that url.query returns a copy, modifying it doesn't change the underlying URL. The fix is pretty simple. We need to store the output of u.query into a variable, make modifications on it, and encode the result back into the URL. So now let's see if we get the expected result. So now the URL looks as expected. Let's look at our third and final example. And I think this is an example where the issue is slightly harder to catch in tests. We first have the fetch customers function. The first thing we do is we have a query which selects a few columns from the customers table. It executes the query with the given context. We iterate over the rows that is returned from calling query context. While iterating, we scan each row into a customer value. The customer value is appended to a slice and returned from the function. Just before we return, we close the rows. Apart from this, we have a couple of helper functions. So the first function, print customers, calls fetch customers, does some basic error handling. And if there is no error, it loops through the result and prints a formatted string for each customer that it got. The demo function just calls print customers twice. So let's see what happens when we run this code. So here we see something unexpected, which is that the output of the second attempt does not match the output of the first attempt. And the underlying issue is somewhere in this code. So can you spot what is the issue here? So the issue is that, so the issue can be detected by a linter called rows ERR check. And the fix is to add a rows.err check after we finish iterating over the rows. And let's see what happens when we run this version of the code. So now what we see is that the second attempt failed with context deadline exceeded. And what we need to understand here is that the context that we set when we call the DB method is also applicable when we iterate over the rows. So it is possible in certain edge cases that the context was valid when the query was executed, but by the time we finished iterating over the rows, the context can become invalid. It could be cancelled or it could be deadline exceeded, right? And if we don't have the check that we have added here, what is going to happen is that we are going to return invalid and incomplete results back to the client with no way for the client to know that the result is incomplete. So this is not a good state to be in. And as I mentioned, rows ERR check can actually help with detecting such issues. All right, so now we have looked at the reasons for using linters, and we have looked at some examples that show how linters can catch tricky bugs. Let's talk about linting specifically in the context of Go. So I'll talk about why I think you should use Golangci-lint. We'll talk about why Golangci-lint needs some configuration to unlock its full potential. And I'll give a brief walkthrough of a configuration builder sheet, which can help you get started. So, so what is Golangci-lint? Golangci-lint is a linter aggregator that provides a consistent, performant interface for running more than 100 linters. It is a very popular project. It is very actively maintained. Additionally, in my experience, the maintainers of this project are very responsive and helpful if you run into any issues. All in all, it is a stellar Go community project, which I would highly recommend that you check out. Now, if you're thinking of adopting Golangci-lint, you might think that all you need to do is run the binary in your project and you'd be done. But unfortunately, that's not enough. By default, Golangci-lint enables a small subset of the linters that are supported. These linters are quite useful and valuable, but there are a lot of other useful linters still disabled. So this list that I have here is by no means an exhaustive list. There are many more that are worth enabling. We already looked at rows ERR check. There's a similar SQL close check, which helps with ensuring correct usage of the database SQL package. GoSec deserves a special mention. It is a security-focused linter, which is able to catch issues like SQL and command injection. Apart from that, we also have GoCritic and Revive. These are linters which bundle a large number of detections into a single tool, and these are also disabled by default, so it is good to enable them. So should you just enable everything, all the 100 plus linters? Again, no. So the thing is, with these 100 linters or more linters that are there in Golangci-lint, there are actually a lot of opinions baked into those linters, right? And I don't think there's anyone who will agree with literally all of the opinions that are present in those linters. So if you were to enable all of them, what is likely going to happen is that you're going to get a lot of noise. You're going to get output from the linter which you don't care about. And it's always very important to ensure that the output from the tools you use is always high signal and low noise. As soon as you have a tool which gives you more noise, you're likely to ignore the output from it thinking it is going to be noise. There's also the possibility that depending on the style of coding that you have chosen for a particular type, function, package, there might be false positives from a specific linter. So it is important to pick and choose the linters that are of interest to you. The next aspect that you also need to consider is that it might be a case that the linter is going to be ineffective until and unless it is used in a specific context. So for example, there is a linter 0log-lint, which is meant to be used with the 0log logger. If you aren't using 0log, this linter is of no use. Another aspect that you need to consider is that with the number of linters that are developed and integrated into this Golangci-lint, it is somewhat inevitable that there would be some duplication of functionality across different linters. And when I had configured Golangci-lint for one of our projects, what I came across was that there were 40 plus instances where the functionality was duplicated across different linters. So that is something you need to take care of. And finally, there's also the case that there are some linters which are performance focused, which I believe you should enable only if your program needs to run in a constrained environment. It is better to write simple code rather than slightly obtuse, more performant code. One last aspect that you need to consider is that some of the linters that you enable also require a bit of additional configuration. For example, GoFMT, which is a stricter GoFMT, it's a very good linter which I would highly recommend that you check out. It includes an optional extra rules which are disabled by default. I like to enable them because I find those rules quite sensible. So for being able to do that, you need this small piece of configuration to enable the additional rules. Now, if you agree that there is actually value in configuring Golangci-lint, but you are daunted by the idea of having to figure out what needs to be enabled from the 100 plus linters, I have something which can help. So typically, you don't need to frequently update the configuration of Golangci-lint if you're using it in a project. And if you're starting a new project, what you're likely to do is you will copy over the configuration from an existing project. But if you don't have Golangci-lint configured anywhere thoroughly, then what's a good idea is to actually use a Google Sheet to collaboratively discuss and decide on the configuration that you want to use for your project. That is essentially what I had done for one of our projects. And at the end, I did not want to manually translate the configuration to a YAML or TOML format, so I just put in a little bit of extra time and work to convert the sheet into the configuration right within the sheet. A couple of caveats I need to mention here is that this particular sheet was last updated for version 1.61 of Golangci-lint. That doesn't mean that you cannot use it with the newer version of Golangci-lint, but you should check what are the new linters that have been added into Golangci-lint since this particular version. And if they are of use to you, you should enable them. I'm also not trying to say that the configuration that I show is the configuration that everyone should use. It is just a good starting point that you should actually tweak and modify according to your needs. All right, with that out of the way, let's look at the sheet. The sheet is pretty simple. We have the list of linters. There's a brief description. There is a column for whether to decide whether a linter is enabled or disabled. There are some comments to explain why a particular linter is enabled or disabled. And if applicable, there is the configuration settings for it. Apart from that, we have a dedicated sheet for Go Critic, which, as I mentioned, has more than 100 detections. There is a similar sheet for Revive, which has more than 75 detections. If you notice, we have enabled just a subset of those checks. We have the header and footer section here, and all the information is actually stitched together for generating this particular configuration. Now, one nifty feature of this sheet is that whenever the sheet is updated, within a few seconds, the configuration is regenerated. All right, switching back. So now let's say you do have the configuration that you want to use. There can still be a problem. If you're integrating the configuration into a new project, there's no problem. You can fix all the issues as and when they arise. But if you are integrating it into a pre-existing project, what is likely is that there would be hundreds of issues reported. And fixing all of these issues at once is prohibitively expensive and can be disruptive for the normal routine work that needs to go into a particular repository. For this particular problem, Golangci-lint has a nifty solution, which is this flag new from rev. The rev here stands for git revision. So you could basically specify either the sorry. You could either specify the previous commit or the main branch, and the issues will be reported in comparison to that particular revision. So what that means is, if you raise a pull request, which modifies two files and adds a new file, all of the issues present in the new file will need to be fixed for the linter step to pass in CI. But for the files that you have modified, only the specific lines that were modified will need to have linter issues fixed. If there are other lines present in the file which have not been modified but do have linter issues, those don't need to be modified for you to actually merge in the changes. There's a good amount of support even in the official GitHub action provided by Golangci-lint, which allows you to report only the new issues being introduced by a pull request. So in summary, linters detect and flag predefined patterns. These patterns can point to potential bugs or code style issues. Using linters helps to left shift detections and improves the quality and speed of delivery. It helps to bring consistency, improves readability and maintainability. It can also act as guardrails. We saw examples that show how linters can catch issues that might be tricky. A bit of extra work is needed to unlock the full potential of Golangci-lint. The configuration builder sheet can be a good starting point for a more thorough configuration. And for existing projects, it is recommended to leverage the new from rev flag provided by Golangci-lint to fix issues iteratively. I want to specially thank the authors of various linters and Golangci-lint. Their work is immensely valuable and it has saved a lot of Go developers a good amount of time. So thank you to them. If you're interested in the material for the talk, you can use this QR code or the short link.
Right, questions? I have one actually. When was the first aha moment you had with the linter, which could have probably saved you all a lot of issues later on? Some experience.
So for me, the first time I came across linters was when I was actually working on Node.js. So when I was working on Node.js, I had these multiple aha moments where the way I wrote code changed completely. And when I came across ESLint, I went through all the rules that were supported in ESLint. I learned a lot about the language. I went in depth configuring ESLint, and that completely changed the way I was writing code.
Interesting. Yes, sir, we have a question coming up.
So if we integrate these linters to our project, okay, and we have a deadlines of delivering the code or binaries, and when we run it, so we see, okay, this issues are there, 10, 15 issues are there, from which we can fix it 10 right now, and 5 is something which will change the flow or needs some more modification. Can we, toggle this off and run and create the binary, or the binary will be created anyways?
Binary.
When we run, when we build, when we build our application.
This has nothing to do with go build. This is a separate step. This is a command that you run separately, which will give the output of what are the issues present in your code base.
Okay, so it will not stop the binary to be created.
It will not stop the construction of the binary.
Okay.
But what you should do is you should have a step in your CI, right, which actually runs the linter step. And if the linter reports issues, you should not allow that build to pass, in my opinion, because what will happen if you allow it to pass is that no one will fix any of the issues, right? And it's important to ensure that your code health is always improving, it doesn't degrade over time.
Thank you.
So adding to that, so the linting does not prevent you from production, but as he said, you should do it. Are there levels? There are the warnings and critical and error levels which come out. Typical linters do that.
So there is actually some support for that. I don't remember the specific flags, but as far as I know, it is possible to change the level for particular linters to depending on how seriously you want to treat it. And it is also possible to feed the output of Golangci-lint to tools like SonarQube, which allows you to visualize all of the problems that are present in a code base. If you are choosing to use the new from Rev option to fix the issues iteratively.
Totally makes sense. I think we have one more question here. Yeah.
I don't really have a question, just something to add. So there was a question about how will it fail the build or not. What you can do eventually on your local system, you won't be running CI, but you can have something called make files, where you have make targets that will fail your build from processing, as you rightly suggested. There is an option to configure your Golangci-lint to have warnings as such, but as you rightly just pointed out, it could be chained to SonarQube. And for those who use VS Code or Vim, there is SonarLint plugin available as well for your local system. That's another addition that you can have as a step. That's my 2 cents.
Perfect. Could you pass the mic? I think somebody had a question right next to you.
So yeah, my question is like, what makes you think to have a common place to put all your configuration instead of check out your configuration to the repository itself, because it will be more upfront to the developer if you put it in the repository itself, and also it can be customizable based on your code base need as well. So
Sorry, I didn't understand the question. Can you repeat it for me?
I mean you created some docs, right, where you are putting the configuration,
right,
and you are changing the values, and I believe the reason for that is you want to make it applicable for all the repositories, right?
Yeah, so there is no good solution for applying a single configuration to all of your repositories, and to some extent I wouldn't do that either. So what I've found in my experience is that the same configuration is good for a starting point, but the configuration needs to evolve as your code base evolves. What I found is that sometimes there are instances where you find that a particular file or a type that you have declared tends to trigger false positives, right? So for that, you will need to add some exceptions. There is good support in Golangci-lint for ignoring a particular file or a package for a particular linter, right? So those kind of things evolve over time. So in that sense, I prefer having a single starting point, but the configuration evolving with each code base.
Yeah, thanks. And also like the second point, why not put your configuration in the repository itself in a YAML or JSON format rather than having a doc?
Sorry, can you please speak
No,
a
I
little
think
slowly?
the Excel sheet that he showed
Yeah.
is the one where you have enabled disabled.
Exactly.
That generates the setup which you are supposed to copy and put into your repository itself.
I see. Okay.
It does not
got
automatically do it.
Yeah, I thought that's the thing which is kind of controlling your,
Thanks.
controlling your configuration in the.
No.
Yeah.
That is just a
It's
helper
just-
Excel sheet.
Yeah,
A
thank
Google
you.
Doc. And
Got
I
it.
think that Google Doc is mentioned somewhere.
Yeah, it is it is linked on the slides.
It's in the slides. So here's the thing. I'm going to ask all the speakers to actually share the slides because some of the speakers' slides have excellent references. So they will be sharing all this. Keep it on that hashtag, #GCI24. You will find all this information there and you'll probably find the links too.
Thank
Okay?
you.
One last question before lunch.
Hey, hi, myself.
Keep it
Sridhar,
short.
sir.
People
Sorry.
are watching. Keep it short. People are watching. Hungry.
So it's a short only. So we are using a codebase, a static analyzer. So how is it different than means can it be replaced with
You're using what?
codebase?
Odyssey
Yep.
analyzer.
Static analyzer.
I am not aware of that.
Okay.
Sorry.
Sonar checkmarks, are you aware of?
I do
Sonar cube checkmarks.
It's part of Sonar Cube, right?
No, it's a different. Codebase is a different analyzer. Sonar cube also supports this static code analysis.
So you can feed the output of Golangci-lint into Sonar Cube.
Okay. So similarly, the same question like for codebase, is it also supported or not? Can I link all these linters into the codebase?
Odyssey I am not aware of.
Okay.